Alright, for number one here, so we have a rectangular jewelry box, cost $125 to gold plate. When we're gold plating, this is going to be a surface area, because we're just going around the outsides of the jewelry box. So we need to find the cost of gold plating a box which is similar in shape and holds 8 times as much. So since it holds 8 times as much, we know that the R cubed is going to end up being 8. So from there we're going to figure out what R is. So we'll take the cube root of both sides. So that tells me that R equals 2. And since gold plating is a surface area, we need to go from R to R squared, which is going to be 2 squared. So that means that R squared is 4 times as much. So we have to do 4 times 125, which gives us $600. Alright, but 4 times 125 is actually not 600, it's actually going to be 500. Alright, for the second one we have to calculate the volume and surface area of this solid right here. So we can see it's made up of 2 half spheres, which we could combine into one whole sphere. And then we also have this cylinder right here. So to get the volume, we know that's going to be the volume of the sphere plus the volume of the cylinder. So I'm going to replace those with the 2 equations that we have for that. So the volume of the sphere is 4/3 pi r cubed. And then the volume of the cylinder is going to be, again, the area of the base times the height. So that's pi r squared h. Well, I've got my radius here, which is 6. So I can put that in. And I've got the height here, which is 11. So I can put that in. So with a little bit of calculator work, we can find out that our volume is going to be 608. Sorry. I should get my calculator out instead of looking at the answer key. So I've got 4/3 times 6 cubed. So we get 288 pi. Plus, alright, well that's 36 times 11. 396 pi. Then we have to add those two together. So we get 684 pi. Which turns out to be about 2150. And then this would be in meters cubed. To get the surface area, we'd have to get the surface area of the whole sphere, because again we've got a whole sphere. But we don't have to find the surface area of these 2 circles for the cylinder. We just want the surface area of the outside of the cylinder. So we want the surface area of the cylinder's rectangle. Well, the sphere is nice because that's just the surface area of the sphere formula, 4 pi r squared. But the rectangle part, remember that's going to be the circumference of the circle times the height. So that's 2 pi r h. So again, I can plug in my 6's. 4 pi 6 squared plus 2 pi 6 11. So I get 36 by 4 over there. So I get 144 pi. And over here I've got 66 times 2, which is 132 pi. So adding these two up, I end up at 200. Alright, so we're back. So the iPad ran out of storage a little bit. We just got 276 pi, and that was 870, about 870. This should be meters squared, because we had a surface area. Alright, so we get back to number 3. We're finding the volume and surface area of the whole solid here. So again, the volume, we want to add up the 2 volumes. So that's going to be the volume of the triangular prism plus the volume of the rectangular prism, or the volume of the box. So I'm going to use the 2 formulas that we have. For a triangular prism, it's the area of the base. Here the base shape is a triangle, so that's going to be 1/2 base times height times the height. Here this is going to be the whole length. So it's going to be a little bit weird because I got 2 different heights in here with 2 different h's. And then I've got the volume of the prism, which is length times width times height. So for the triangle, we've got 1/2 times the base, which they tell us is 12, is the base of the triangle, times the height of the triangle, which is 9, times the height of the whole prism. And in this case, this is going to be the depth, which is down here, which is 4 feet. And length times width times height is that of the square, or sorry, that is that of the prism. So we got 16 times 4 times 6. So I need to multiply these all together. These ones will come together to become 216. These ones will come together to become 384. So altogether I've got 600 units cubed. So that's the volume of the shape. We also need to find the surface area, which is a little bit tricky on this one, because this square part right here is not part of the surface area. So we have to somehow figure out all of the faces except these ones. So what I'm going to do is I'm going to say that the surface area is that of the entire box, of that of the rectangular prism, minus the surface area of this little square piece. And then the other part is going to be the triangular prism, but not this square bottom piece. So plus the surface area of the triangular prism, but not this bottom square piece. So again, I got to subtract the square again. So that's going to be my general plan. So to get the surface area of the rectangular prism, I'm going to find the surface area of each side and multiply by 2. So it's going to be 2 of these front faces. So that's 12 by 6. No, not 12 by 6, 16 by 6. It's going to be 2 of these ones over here, which is 4 by 6. And it's going to be 2 of the top and the bottom, which is going to be 16 by 4. So I'd have to add all those up together. To get the surface area of my little square piece, which I guess is not really a square, so I shouldn't have called it a square, it's really a rectangle. So that's going to be this 12 by how far this is, which is 4. That's the same over here. So then I need the surface area of my triangular prism. So that's going to be my 2 triangular bases, which is going to be 1/2 times base times height. And we have 2 of those. And then we also need to find these 2 pieces. So we need to find the surface area of all of my other panels. So the back should go a little bit faster. Here we're given a few things that we're going to label in here. We know AB is a diameter. So DAB is 65, DAB. AB and EF are parallel. And the measure of EF is 88 degrees. So we need to find the measure of FB. Well, we don't know what these angles are yet, but we do know that these 2 angles are the same because they're alternate interior angles. Since those angles are the same, it means that the arcs that they make also have to be the same. We're given AB as a diameter, so we know all the way around there is halfway around the circle, or 180. So to find FB, we can do 180 minus 88. So that'll give us these 2 pieces. So then we'll have to divide that by 2. So we can do that. We can just divide by 2 right away. So that's 90 minus 44. Or the measure of FB is 46. So we get our 2 measures of our 2 arcs. To get the measure of BAF, we know that the arc is twice as big as the angle. So 46 divided by 2 is 23 degrees. The measure of AE is the same as BF, so I already got FB, so it's going to be 46 again. The measure of AD is this piece right here. Now we also know that around here we get 180. And we know 65, well, the arc that we make with this angle is going to be 65 times 2, or 130. So the leftover piece, we have to do 180 degrees minus 130 degrees, and we get 50 degrees for AD. Alright, So our next step is to find DCB. Well, DCB, well, we already found that because we knew it was 65 times 2 was 130. So we got that down. And lastly, they want us to find ADB. Well, every triangle in a semicircle, since this was 180 degrees, is always a right angle. So that's 90 degrees. For the next one, we had to use our rules with tangent. If we know GJ is tangent to circle K, we can draw a radius there and make a 90-degree angle. JG is 8, KL is 6. Find the length of KG. So you'd have to do Pythagorean theorem, 8 squared plus 6 squared equals C squared. Or you can use, it's a 3, 4, 5 triangle times 2. So C is going to end up being 10. For the next part, we had to find the value of x. We looked at our chord rules. We know that that's 5 times x equals 3 times 11. 5x equals 33, or x equals 33 over 5. So we're all set there. The last one we had to do, we're given a radius and a chord. We have to find the measure of the arc. So I'm going to draw a picture. It's got a radius of 10, and chord AB has a length of 15. So we practice these ones in class. Where we have to do is make a nice triangle here. So I'm going to make a triangle. I'm going to redraw my triangle over here. So since this is a radius, we know that this is 10 and this is 10. We're given this whole length is 15. And we got to split this down the middle, which makes this 7.5 and 10. Since we're interested in finding out the measure of the arc, we need to get this angle to get to this angle to get back to the chord. So if I call that one theta, I know I've got my hypotenuse and my opposite, so I can use my trig rules. So sine, I'll call that x, sine of x is equal to SOHCAHTOA, opposite is 7.5 over 10. So to undo that, I know that x is equal to sine minus 1 of 7.5 over 10. So I can find out that x is equal to 48.6 degrees. So that's the measure of this. I know this one's twice as big, so that's 2x. So I can do 48.6 times 2, which is 97.2. So I know this is all 97.2. And then I know this is twice as big as that. So I got to do 2 times 97.2. Oh, sorry, take that back. This is a central angle, so those are the same. Those actually aren't twice as big. So since we got our central angle, we get the same thing. It's just 1 times 97.2. So we end up at 97.2 degrees.